Hello, some viewers. How are you all? Welcome back to another video. Guys, in this video, we are going to discuss what is Bayesian and also we'll see one simple program to explain it. So, Bayesian reasoning is like, for example, there are probabilities, right? What exactly is a probability? Now you may ask, okay. So, what is Bayesian reasoning? Imagine you're a detective trying to solve a case. You have a case, you're trying to solve it. You have some clues called evidence, a suspect category, but you need to figure out how the suspect is a culprit. Traditional court case. Now you have a category, you have an evidence, the knife, something like that. You have suspect in a different category. Suspect, the evidence, they are the clues. The suspect is a category. But you need to figure out how the suspect is a culprit. Bayesian reasoning is like a detective throughout the thought process, constantly updating the suspect likelihood on the new information. Now, Bayesian reasoning will give you the new information always. So everything has a chance of being true. Bayesian reasoning uses numbers probabilities to represent the chances between zeros and one. So fuzzy logic, you understood, right? Fuzzy logic, it's not black and white, but actually it takes an account somewhere in between. Okay. The probabilities are also like that. So zero means it's impossible, one means it's certain. So number between the different likelihoods priority. This is initial guess. What is the prior probability? This is the initial guess about a suspect's likelihood. Means what? We are guessing first probability. So Bayesian reasoning is all about probabilities. Everything has a chance to be true. So suspect can be a murderer. Suspect can be innocent. So it can be true either way. So now, like how suspicious they seemed at first. So now you are deducting everything. How suspicious the suspect is at first. Now we'll take an evidence. Evidence what we have put is clues. So here we are taking evidence. These are the clues you may find. Let's say fingerprints you have got. So updating will based on evidence you adjust your initial guess prior probability. So we now got the fingerprints. Based on the fingerprints, now we are adjusting the final deductivity. So you suspect your neighbor stole you cookies. Suspect equal to neighbor. Just like how you saw the suspect initially it can be true or false, and based on the fingerprints we got based on probability, prior probability. So now what is the prior probability here? You haven't seen them around, so cookies before. Maybe it's 0.2. So we are giving a number between 0 and 1. Meaning not very likely. What is the evidence here? You find crumbs leading to the door. No. So evidence now you go. So initially you're giving prior probability, maybe 0.2 because you're not sure yet. So finally, when you got to know you find the crumbs at the neighbor's door, it's a strong clue, right? Now you will update the belief. With the evidence, you might raise your belief to be 0. More likely that okay, this guy would have taken. So Bayesian networks are like mind maps for detectives showing connection between suspect, evidence, and how they influence each other. Okay. Now we'll see a program of Bayesian. Now, understand the probabilities here. It is very, very important. So we'll take an example of rain. What the probability of rain? So we are taking an example, rain prior probability based on prior probability is 0.3. If it's cloud given rain, then it's a probability that definitely cloud will have rain, right? So it's a likelihood of it cloudy. If it's cloudy, it can rain. So probability of rain usually, if it is not cloudy, let's say we have given 0.3, it's based on probability. Cloudy today, so it is true. So cloud given rain can be 0.9. Based on that, we have added a program. So posterior probability we have given. If it is sunny, not given rate is 0.01. Then we are calculating based on total likelihood and we are returning the value what is the total likelihood. Okay. So rain posterior, this is what first one. Posterior probability, we are giving the posterior probability. We are giving all the three values. What is rain prior? 0.3. What is the cloudy given rain? 0.9. If it is cloudy today, true. Based on that, we are calculating this one. We are printing the result. If rain posterior is greater than 0.5. It is kind of similar to fuzzy logic, but it always rains on probabilities. It is more likely to rain today based on cloudiness, as it is less likely to rain. So now let us run with few examples. This is Bayesian, right? Bayesian.py. So probability of rain we have given 0.3, 0.9. Observe side is cloudy today. So posterior probability is 0.7. It's more likely to rain today than the observed cloudiness. Hope you like the video, guys. If you like the video, please click on like. If you're a new viewer, please click on subscribe. Till then, guys, take care. Have a great day. Bye bye.